Hi, Moeno here. In fact, if you're here today, it's because probably you hear about QuickSort Algorithm and you don't know how it works. Or maybe you know how it works, but you just get the big picture and you don't really understand how it is in details. Whatever it is, stay here. You are the right place. I'm gonna explain you from scratch what the QuickSort algorithm is, how it works, and by the end of the video, I'll answer some common questions that you should know about QuickSort algorithm. And as always, if you don't like the video, please don't subscribe. But if you do like it, please subscribe. Click on the notification icon so you can receive a notification upon our next video. And also, don't forget to like the video. That will help with YouTube algorithm. Too much talking, let's get started. QuickSort algorithm is one of the fastest algorithms to sort array that we can find in the family of divide and conquer algorithm. When it is well implemented, it has an average running time of O n log n. When it's not, it can have a worse running case of O n squared, and by the end of this video, I will explain you what can cause the worst running case. To start, we are going to have an array of size 7. Of course, it can be any number of elements. Now, let's mark the index of every single element. Here, we're gonna have 0, 1, 2, 3, 4, 5, 6. Remember we say that the size of our array is gonna be 7 and now we see 6 is because by convention we always start counting the index of an array by 0. Here we have an array of size 7. One of the most important things that I want you to know about QuickSort algorithm is partitioning. To do so, we have to choose a pivot, and after choosing the pivot, we need to partition our array into two parts. In the left side, we have the elements lower than the pivot. In the right side, the ones greater than the pivot, and we do so recursively. But how to choose the pivot? There are many ways to choose the pivot, but the three common ways are whether you choose the first element, in this case that would be 5, or you choose the last one, that would be 7, or you choose the median. How to choose the median? How to find out the median? It's very simple. You take the index, the first index, that is 0, plus the last index, that is 6, divided into 2, that will give 3. In this case, the median will be the element at the index 3. Our median, in this case, would be 4. And for the purpose of the class today, we are going to use the median method. And by the end of the video, I will explain you why we are going to choose the median method. Now, we already know that our median in this case is 4, and I already show you how we find it. We select it. Now, there are two things that we need to check. We need to check how many elements are lower than our median, that is the pivot, and how many are greater. In this case here, we have 1, 2, 3, 3 elements that are lower than 4, and 5, 6, 7, 3 other elements that are greater than 4. Now, we are going to create two sub-arrays, one with 3 elements on the left side and another one with 3 elements on the right side. Now we are going to place every single element in the position where it should be located. But here, as you can see, for example, here you see that we have 6 places. Don't be confused. We're gonna use the 3 first one, and the 3 other one gonna be used later on when we finish sorting the sub-array. Okay, so don't be confused. Let me erase it. Okay, so the, the number 5 is greater than 4. Number 5 is gonna be here. Number 3 is lower than 4. It's gonna be here. 6 greater than 4. Number 2 is lower, number 2 is gonna be here, number 1 lower is gonna be here, and number 7 is greater is gonna be here. Okay, now forget about this subarray for a while. We are going to work with this subarray, and when we are done with this subarray, we are going to work with the second one. Okay, great. Now number 7 here, one sec, number 7 here, wait. Now the same thing that we did for the big array, we are going to repeat the same process for our subarrays recursively. To do so, let's first mark our index. The index that we have here is um, 0, index 1, and index 2. And here the index that we have is index 4, index 5, and index 6. Okay, now we are going to find the pivot here. Okay, how to find the pivot? The same process. We say the first index 0 plus the last one 2 divided into 2 is gonna give 2 into 2, and it's gonna give 1. That means the element at the index 1 is the pivot. In this case, our pivot is 2. Okay, now we know our pivot. Now let's count. We have one element lower than 2 and one greater than 2. So that means on the right side, on the left side, we are going to have one spot for the element lower than 2, and on the right side, we are going to have another spot for the element greater than 2. Okay, fine. Okay, now the number 3 is gonna go here because it is greater than the pivot. Number 3 is gonna go here, and number 1 is gonna go here. It's lower than the pivot. Now there is something really interesting happening. We stay with only one element. There is no way that we can divide anymore, because remember that QuickSort algorithm is a divide and conquer algorithm. As soon as you reach to a point that you can't divide anymore, it's time now to start merging. Okay, so now because we cannot divide one element, because it's only a subarray with one element, now we need to say that 1 is 1. Okay, it's sorted. If an array has only one element, this array is already in sorted order. There is nothing to do. The same thing is going to be repeated for the number 3. We can say also that the number 3 is in sorted order because it's only one element. Okay, we're gonna put number 3. Okay, it's gonna return 3. Now, here at this level here, okay, this level here, we going to sort. How we gonna do that? Now, this one is gonna take this position because it is on the left side. Okay. The 2 will come after because it is the pivot, and the 3 will come after because it is greater than the pivot. Now we already have this subarray that is in sorted order. Now we are done for this subarray. It is time now to work with this big subarray, and we are going to repeat the same process that we already repeated for the first subarray. Okay, it's very simple. Okay, here when I say here, I mean these subarray. Okay, so here we need to find out the pivot. Okay, to find out the pivot, remember we have our formula, and our formula says we need to take the first element plus the first index plus the last index, and we divide it into 2. In this case, the first index is the number 4. Okay, plus the last index is number 6 divided into 2. In this case, 4 plus 6 give 10, divided into 2 give 5. In this case, the pivot is the element that's located at the index 5. In this case, our pivot is 6. Now that we know our pivot, we can start partitioning because the pivot is the only thing that we need to know to start partitioning. Because the partition, we're gonna have the element lower on the pivot at the left side and the one greater on the pivot at the right side. Here, we have one element lower than the pivot, which is the number 5. Number 5 is gonna be here. And we have one element that's greater than the pivot, that's the number 7. Number 7 is gonna be here. Okay, this is not 7, this is an arrow. Okay, don't get confused. This is an arrow which represent like a return sign. Okay, this is an arrow. Great. Now we get to a point very important. Number 5 is only one element. It is an already sorted sub-array because, as I already told you for the first sub-array, as soon as you have an array with the size 1, this array is already in sorted order. You just need to return. There is nothing that you can do anymore. Now we return the 5. We're gonna do the same for 7. Now we can go up. Okay, so we have the first sub-array at the left side, which already in sorted order. We're gonna say 5. Now it's time to put the pivot, which is 6. Now it's time to put the right sub-array, which greater than the pivot, is gonna be 7. Now we have two big sub-array in sorted order. Okay, what we're going to do now is the first thing that we are going to do, we are going to report here the first sub-array, which is 1, 2, 3, plus the pivot, which is 4. Here it is 4, and plus the right sub-array, that is 5, 6, 7. I'm sorry, my 5 is like a 6. Don't get confused. 5, 6, 7. And finally, we have a sorted array using QuickSort algorithm. Fine, guys. Remember, I promised you by the end of the video, I'm gonna explain you why I choose the median method. It's kind of very simple. I choose it because it is better for you to not get in what we call the worst winning case. The worst winning case, let me give you an example where you can get the worst winning case if you're not using the median method. Let me show you. Let me erase everything. Let's say that you have an array of 7 elements, okay? But you get this array like that. 1, 2, 3, 4, 5, 6, 7. And you choose, you don't choose the median method. Instead, you choose the method where you choose the first element or the last element. Now, let's say that now our pivot would be 7, okay? Our pivot would be 7. And when we are going to partition, we are going to have the elements that are lower than the pivot on the left side and elements that are greater than the pivot on the right side. In this case, the elements that are lower than the pivot are 1, 2, 3, 4, 5, 6. And we don't have any element that are greater than the pivot. And this is gonna repeat continuously. And there you get the worst winning case, and the winning time is gonna be O(n) squared. Okay, so that means if you already have an array in sorted or reverse sorted order, and you use the method where you choose the first or the last element as the pivot, you're probably gonna get in the worst winning case. So it's always better to use the median method because there is it's much more better for you to get the average winning time of O n log n. Okay, so that's very important for you. It's kind of very simple, guys. If there is something that you don't understand, please you can comment, and I'll be more than happy to give you a much more explanation on the comment. If that require me to do another video to explain better how this algorithm works, I'll do it, because remember, it is very important for you if you'd like to be higher in like some big tech, to master those algorithms. Again, thank you very much, guys. So if you do like the video, please don't forget to subscribe to our channel. Click on the notification icon so you can receive a notification upon our next videos. And please, again, please, guys, I please you, like the video. Thank you so much.